Okay, we need to talk about IPv6. But before we talk about IPv6, we need to talk about the reason we need IPv6. And the reason we need IPv6 is that we're running out of IP addresses. We'll explain why. ICANN, the Internet Corporation of Assigned Names and Numbers, I believe is what that stands for. And they are, well, they used to be a US-based company. Very, very recently, we have kind of begun turning over control of ICANN to an international consortium, meaning the United States is not as in charge of the internet as they used to be. And the Internet Corporation of Assigned Names and Numbers is responsible for domain names. They determine what top-level domains we have. When we talked about DNS and all the new top-level domains, that was ICANN's decision. They're also in charge of IP address assignments. And that means that those public IP addresses, that list of public IP addresses that are available to use on the internet, ICANN is the organization in charge of handing those out and basically in charge of deciding who gets to use those. The IANA, Internet Assigned Numbers Authority, I think is what that stands for. You can Google it. They're a subpart. They're under control of ICANN, and they manage the distribution of IP addresses specifically, and they manage the root zone servers for DNS. But for what we're concerned about here, they manage the distribution of blocks of IP addresses. Now, they're not the ones who are handing you an IP address at your house to use on the internet, or the ones handing you an IP address at Starbucks or wherever you go. But they are the ones who manage basically who has what IP addresses on a global level. Now, IPv4, the version that we're currently using, the version that we are on right now, was deployed January 1st, 1983. Now, if you think about what the internet looked like in January 1983, not a lot of people on it, not a lot of organizations or companies or basically anything. Nobody had a computer at their house, right? The internet looked completely different. It really wasn't until the 90s that the internet started to spread. So IPv4, 32-bit addresses, which gives roughly 4 billion possible addresses total. Now, what that means is, well, in 1983, that looked like a lot. 4 billion addresses was a lot of addresses. That's a lot of computers. That's a lot of people connecting to a network, because even if you had a computer in 1983, it probably wasn't connected to the internet, because it was a very fledgling network at that point. So it looked like a lot. Not so much anymore. It doesn't so much look like so many. 4 billion is not enough for every person on Earth to have an address on the internet. And if you think about it, think about how many devices you own that are connected to the network. I have 1, 2, 3, 4. I have 5 sitting in this room with me right now. 5 different computers and devices and things that are connected to the internet right now with me that are mine. That's not including the desktop and other computers that I have at home, which means there's not enough addresses for all the devices to be connected to the internet. So the way IP assignment works, I told you the IANA is the one in charge of that. The way they decide, they take a block of IP addresses and they hand those addresses to what's called a regional internet registry. Now, there are 5 regional internet registries: ARIN, LACNIC, AFRINIC, RIPE, and APNIC. And these are global regions. So ARIN is North America, LACNIC is Latin America, AFRINIC is Africa, APNIC is Asia Pacific, and RIPE is Russia and the Middle East and Europe. Now, these are given blocks of IP addresses. For example, the 10 dot something network. Well, that's a private network, so that's not given to anybody. But the 11 dot everything, that might be handed to ARIN. And the 12 dot anything could be handed to RIPE. And 13 dot anything could be handed to AFRINIC. Or it could be chopped up into smaller pieces. So 13.25 could be given to AFRINIC, and 13.26 could be given to APNIC. It really depends on the needs of the network and the needs of the regions, how we assign those IP addresses. And then those regions have the option, depending on the needs of the country, they might give IP addresses or blocks of IP addresses to a national or a local internet registry. And these varies depending on the size of the country. You might have a national internet registry for your country, or even then within your country, you might have local internet registries that are even smaller, that cover even smaller areas. So I don't know what the details are in the United States, but there might be multiple local registries covering different parts of the country. So the regional internet registries assigns those out. And then the local, national, and the regional can all assign IP addresses, again, depending on the needs of the region, can assign IP addresses to an ISP. So my ISP is Cox. They've purchased a block of IP addresses to hand out to their customers. And ISPs are the ones who are responsible for providing internet, providing internet to me, but providing IP addresses for their users. So if you wanted to start an ISP, you would have to purchase a block of IP addresses that you could hand out, a block of these public IP addresses that you can hand out to your users. Well, you can pull up this list if you'd like, take a look at the IP address assignments that have been assigned by the IANA. Now, this isn't exactly correct because some of these organizations have given back IP addresses, but when we were handing out IP address assignments in 1983, we were not very careful with them because, again, back then we had lots of IP addresses. We had 4 billion addresses. It was no big deal. There were only so many devices on the network. We gave out chunks of 16 million IP addresses, which is a Class A network. If you remember back to when we talked about IP addressing, a Class A network of 16 million addresses was given to an organization. One organization, like Apple, like Ford, if you look at the list, there's a lot of them. Each of these organizations was given 16 million addresses, which takes those addresses and says, Apple, you're the only one who can use these. Nobody else can use them. Or Ford, you're the only one who can use these. Nobody else can use them. Because that's the way the network worked. You had classes of IP addresses and that was it. So we handed those out very cavalierly to pretty much anybody. The problem with that is that now those 16 million IP addresses that we gave to Apple, when Apple might need maybe 1 million, right? So that's 15 million addresses, and that's being generous towards how many IP addresses Apple uses. That's 15 million addresses that can't be used, that are assigned to Apple, but they are not using, which means nobody else can use them. So that's a problem. That's a bunch of wasted IP addresses. And now that we're getting to where we're running out of IP addresses, well, that's why. Part of the reason why. So how much do IP addresses cost? If you had gotten on the bandwagon a little bit earlier, it's a lot harder to get a block of IP addresses now, and we'll talk about that in about 2 seconds. But from IANA, the North American Regional Internet Registry, you could buy a block of IP addresses of size /22 or smaller, which is about 1,000 IP addresses, for $500. And you would pay that every year. Annually, you would pay $500 for that 1,000 IP addresses. And if you want larger networks, obviously it gets a little bit more expensive, up to 4,000 IP addresses. You could have $1,000 or up to roughly 1 million or 500,000 addresses, I think, for those $32,000 blocks of IP addresses. The problem is we're running out. And in fact, the regional internet registries no longer have addresses to allocate. Asia Pacific, RIPE in Europe, LACNIC in Latin America, and now IANA in September 2015 have all run out of IP addresses. You cannot purchase a block of IP addresses from any of those regional internet registries. The only one that has anything left is Afrinic, and they're going to run out too. Not as quickly, but they're going to run out. But you can only get addresses from Afrinic if you live in Africa. So all of the regional internet registries are out. We might have national or local internet registries that still have some that they've purchased from or been allocated from the regional internet registries, but they're out. They're all out of IP addresses. We are out of IP addresses, and we're kind of in crisis mode in a way. I mean, the internet's still working and chugging along just fine. So why? Why are we running out of IP addresses? There's so many reasons. Mobile computing, if you think about that. Mobile computing added a cell phone to everybody's pocket that wants to be connected to the internet. Possibly also a tablet in everybody's backpack that wants to be connected to the internet, and a laptop. and maybe a desktop, and other Internet of Things type devices that also want to be connected to the internet. And that we have just drastically expanded in the past 10 years the number of devices that need to be connected to the internet or that want to be connected to the internet. We've also made a move towards always-on devices. So back in the olden days, when you wanted to connect to the internet, you dialed in at night and connected to the internet for a couple hours and then you disconnected. And that meant that that IP address that you had, you only needed it for a couple of hours. And then when you disconnected, somebody else could use that IP address. Well, now I never shut mine off. Nobody I know ever shuts theirs off. And so everybody's devices are always online. And that inefficient address use that we've talked about, where Apple got 16 million addresses all for themselves and Ford got 16 million addresses all for themselves, well, that meant a lot of wasted addresses there. And finally, and probably most importantly, there are more people who want to get online. The internet used in the 80s was a very niche thing. And now, basically, it's the goal of the world to get everybody online because of the great benefits of being in a connected society, and that globally connected society. So, we're out of addresses. And that is why we're at this situation where we're at, where 4 out of the 5 regional internet registries are out of addresses. So what do we do in the meantime to buy time before we make this conversion, this grand conversion to IPv6 that's going to save the internet and everybody's going to have IP addresses to spare? Well, there's a few different things. NAT and PAT we've already talked about. Inside of my local network, inside of the wireless network on campus here, you can connect to the internet through a single IP address. And 10 devices or 20 devices or 50 devices can all connect to the internet using one single public IP address. So that's one way. Classless routing. When we talked about IP addressing, we talked about classless routing. The difference between being forced to use a certain subnet mask based on the class of address, the class A, class B, class C, versus being able to take those class A networks and subdivide them and create subnet masks that split those 16 million device networks into a whole bunch of 1,000 device networks or even more 250 device networks. So being able to do that, classless routing, was a big step towards saving that because it fixed some of that inefficient address use that we had. Another couple we'll talk about, well, private address is kind of related to NAT and PAT. It's saved from having to get online. But then I also want to talk about virtual hosting. Virtual hosting is something that you've used if you've ever used a web host like DreamHost or who else? HostGator. Those kinds of companies use what's called virtual hosting. And what that allows them to do is connect multiple different sites using the same public IP address. And the way that you do that is you set up DNS records for each of those sites to go point to the same IP address. So in the case at the bottom here, we have www.example.com. That's going to point to 168.2.2.2. And blog.example.com is also going to point to 168.2.2.2. And when your HTTP request gets to the web server like Apache, Apache is going to look at that and look at the URL that you're visiting. So it's not looking at the IP address, it's looking at the URL, the domain name in the URL that's indicated in the HTTP request. And then it's going to basically pull up a different folder depending on the URL. So if you're going to www.example.com, it's going to go to that homepage folder. If you're going to blog.example.com, it's going to go to the blog folder. You could have a completely different one that's sandwiches.com and have sandwiches.com go to a separate folder. And so when you're using a web host like HostGator or whoever, you're basically given a folder on their setup, and they configure Apache for you. And so on one IP address, you have one folder, and they configure Apache to point your domain name to that folder. So when you visit your domain name, you're accessing your folder, and you can do whatever you want within that folder, but you're not accessing the root of the server and changing, and you're not going to see anybody else's stuff unless they screwed up. So this is what the configuration might look like in Apache. You can look at that, pause the video and look a little bit more in depth at that, but you can see it points out the document root, which is the folder, and then the server name, and possibly an alias as well. So you can point multiple names to a single document root or folder. So that is it. That is why we need IPv6. We are out of addresses in IPv4, and we've got a couple things that will stall or put off the eventual apocalypse that will happen when we run out of IPv4 addresses. But eventually we're going to need to move on to something bigger and better that has more than those 4 billion addresses.